are doing related rates. We've done them last year. And on the AP exam for BC, you will have either a vector or a polar or a combination of those two. You will have a Taylor polynomial. Those are the guarantees. I have never seen the AP exam without a Taylor power series. Taylor series and a power series are the same thing. It's just how you generate it. That's all. Okay. And the third problem, the third BC problem is kind of up for grabs. It's usually a differential equation with a BC topic. We call it a double bubble. There are two parts to it. You have 4 parts for the BC and 5 parts for the AB. It will not be a common problem. Will not be the same as the AB test. But it will have AB topics and BC topics. So you have that. Why do I call it a double bubble? You get 2 scores. So I actually have to bubble in on the scan for on your AB score and your BC score. So it's not that big a deal, but it does have both topics in there. Then you have 3 that are common problems. It's a good chance we have not had a related rate problem. It's a good chance it'll be a related rate. I have not had one of those in years. So I think we're due for it, but I said that last year and I was wrong. But I do know you will have a vector and you will have a Taylor, or else it's polars. Now, we haven't had polars for a while either. So, and polars and vectors are highly related, so it could be a combination of those two things. But let's review how to do related rates. And they're called related rates because you're going to relate rates in a problem. And so when I do this problem, and I think at the end of my slide, I believe, I have all the steps here of what you do. But we're just going to go ahead and do it. So first I read the problem. That's really kind of important. So a small balloon is released at a point 150 feet away from an observer who's on level ground. We are in a perfect world. If the balloon goes straight up at a rate of 8 feet per second, how fast is the distance from the balloon to the observer increasing when the balloon is 50 feet high? There's a lot of information there. Things that are constant, I will go ahead and label on my diagram. He's not moving, just like you guys do your coffee in the morning, right? So this is 150 feet. That's fixed. The when is not fixed. And that's what the biggest thing that everybody does wrong is they want to plug in the 50 right away. No, it's a snapshot. And I don't think I can get that to stop. But at some point, it's going to be looking like right here. And that when is going to be the 50 feet there. So I'm going to put it here. I'm not going to put it on my diagram because it's not always there. And it says, so I've got rid of some things, the balloon is going straight up at 8 feet per second. So that's what's given, 8 feet per second. How fast is the distance from the balloon to the observer? So the observer's here. There's the distance from the balloon to the observer. What do you want to call that? Because I don't know what it is. I don't want to call it X or Y because then it's confusing. Z. Okay, that works. Is this distance changing? Yeah. So what do you want to call that one? Y. Call it H. I don't really care what you call them. Although I don't want to, X and Y, always have their own meanings. Okay. So what is the 8 feet per second? It says the balloon goes straight up at a rate of 8 feet per second. That's the change in what? Corey, what is that? Good. As what changes? As time changes. Derivative is always, how does one thing change if you change another? Remember how to do these? And what do I want to find, Ori? I don't have an X there. I want to find how fast the distance from the observer to the balloon is changing. dz dt. Now, I don't know if I do this differently than the other teachers, but I go right here and say, what is it I want to relate? Because this tells you you want to relate Z and Y. Okay, Eric? I want to relate those two things. How can I relate those given the only information I have, which is my diagram? Before I get to the rates, I want to relate Z and Y. Look at your picture. What's the relationship there? Whose theorem? Pythagorean theorem. Now, if I were relating an angle, I wouldn't use Pythagorean's theorem because that doesn't deal with angles. So I need a Z and I need a Y. So Y squared plus 150 squared equals Z squared. Is that okay, Trevor? You've never seen this before, so you really need to pay attention. Okay. That's the relationship in the function. Now I want to relate the rates, so what am I going to do to all parts of this? Take the derivative with respect to what? Time. Now, am I going to solve for y or z before I take the derivative? No. That's too hard because you get the square root. Some of you will do that, and I will say to you, when did we ever do that in class? Do this implicitly. Remember implicit differentiation, chapter 3. You just take the derivative as written. What's the derivative of y squared? That's the derivative with respect to y. Then you have to chain it times the derivative of the inside function with respect to time. Does that make sense? And for those of you new, just don't be afraid to ask questions. Plus, and I usually see 2 times 150 here, but that's not true. What's the derivative of a constant? 0. Equals, and what's the derivative of z squared? 2z dz dt. I like to simplify what I can. I can divide both sides by 2. Because I like to keep things as simple as I can. Okay, guys? Now, what do I know here? I know a bunch of stuff. I know dy dt is 8. I want to find what? dz dt. Hey, what's the 50? What's the 50? That's y. I divided by the 2's, so I got rid of them. So y was 50, right? Z, dz dt, but I can find z, because at the precise instant, when I take the picture, this is what, 150, and this is 50. Well, we're going to find the hypotenuse, and we know how to find it. Now, let's pretend it's not a calculator problem. No, not really, because all these triangles are similar. Once you have a right triangle, there's another one that's similar to it. Let's divide. It's not 3 4 5, but it's a good guess. It's 50. Let's reduce it. This side would be 1, and this is 3. This is just 50 times bigger. That's all. So what's this side? It's the square root of 1 squared plus 3 squared is 10. So that's the square root of 10, and this would be the square root of 10, but to get back to this, we have to multiply by 50. Now, if it's a calculator, you can use your calculator. Or you could even leave it, the square root of 50 squared plus the square root of 150. Sorry, I said that wrong. Square root of 50 squared plus 150 squared. Who cares? If it's free response, we don't care. So I want black. So 50 times 8 equals 50 times the square root of 10. Okay, Eric, do I really want to use a calculator? Because if I do use a calculator, I must always have how many decimal places? 3. True, but you must have 3. I've been grading for 3 years. You know how many times I have to take off points because people went to 2? A lot. And that's a bad thing in your grade. Now, once you round wrong on the one problem, I only grade one problem at a time. You only get penalized once. But if somebody else will grade your other problems, if you do it all the way through the exam, that could be up to 9 points you've lost. Not 6 points you've lost, which is almost a free response question. So no. So why not just leave it exact? Takes less time, and I'm done. If they ask for units, then put units in. If they don't, just ignore them. Now the problem, unfortunately, in your homework are harder than this. You know why I don't give you the easy ones? You already know the easy ones. You've already done them. So you're going to do the hard ones. But then you'll be better at the easy ones if you get them. But they're never easy on the exam. That's good old Pythagorean theorem. Next one's harder. Now, sorry, I had a little problems. I couldn't find water pouring in when I tried to do this. You guys know what a cistern is? No. Good guess. It's a well. And when I lived on my farm, I had a rectangular prism for a cistern. Okay, so the water would just seep in, groundwater would do that, and then I could water my horses. But then it dried up, and so then I had to actually go and get the hoses out. Well, when it's 10, 11 below like today, it's not fun to get the hoses out because then I got to put them back in the house because they freeze. And it was a long ways from the faucet to the horse barn. It was not fun. But the water is supposed to be just coming into this cistern, and why it would be in the shape of a cone, I have no idea, but it is. So you've got water going in, and it says it's coming in at 8 cubic feet per minute. That tells me a lot. What is that the change in?
Cubic feet.
Cubic. A is a good choice, but it's volume, right? CC. And it says the height is 12 feet, so this height here is 12. The radius of the opening is 6 feet. How fast, let's see, that's 6 feet. How fast is the water level rising? So the water is going to be at different places. It could be here, it could be here. You know, I don't care where it is. It's just someplace. So add a snapshot. Let's just keep the one we did, first one I did. I want to know how fast this is rising. Is it going to rise faster in the beginning or later? The beginning. And is the radius going to change? Yes, the radius is not constant. Cylinder, it would be constant. Okay, it says when the water is 4 feet deep. Now I'm going to use H and R because that makes sense. So the when is when H is equal to 4. How fast is the water level rising? What do I want to find? dy. I don't have any y's. You could call it y. dr would be the change in the radius. I want how fast the water level is rising. They could have asked us that. And that's why I always do this. And by the way, you get your point probably on this problem for that statement right there. So why not put the whole thing in? So I want to relate H and V. Okay? Do you guys know the formula for volume? 1/3 pi r squared H. No, they don't do that. They give you the formula. That's even easier. If you're an IB, they give you a formula sheet, but not here. And so I want to keep H and V. So I have to get rid of R. If it had been R and V, then I would get rid of H. Okay? See what I'm talking about relating it? This tells me which variables I want. Okay, so I have an interesting situation here. I have similar triangles. I have this big one. Excuse me. So I'll pull out. And then I have this little one here. And they're similar by angle similarity. Okay, Nick? This is 6. This whole thing is 12. This is H. It's not a constant. And this is R. Do you remember similar triangles? Nope. R is not a constant. H is to 12. As what? R is to 6. But where's the common mistake? Putting H equal to 4 right there. Nope. Because both R and H are changing. You can't put any constants in until the very end because it's not always constant. The only ones you can keep in there are the ones that are always constant. Yeah, you won't get very far in this problem if you put the 4 in right away. So I want to get rid of which variable? Eric, which one do I want to get rid of here? I want to get rid of R, right? Good. So I'll multiply by 6. Sorry. So multiply by 6. So R is equal to 6H over 12, and I don't want to deal with those big numbers. So that's R is equal to 1/2 of H or H over 2. Same thing. And that's what I'm going to put in for R. You're right. There was a 2, but that might be by chance. So it's R squared H I'm going to put that r in there, which is h over 2. Now, what happens if you guys forget to do? You forget the what? Parentheses. I see it all the time. Now, if you forget your parentheses but come up with the right final equation, you're okay. Now, that's been the last 3 years. That doesn't mean that this year that they'll accept that. Probably. I would say they probably will. Okay, so volume equals 1/3 pi. That's h squared over what? 4. Because you got to square that. Then you want to simplify it because you don't want to take the derivative. Because if I do, I have to use the what rule? There's a big time sign there. Product rule. And you can. It's just harder. So in the numerator, I have pi. In the denominator, I have 12. See where that's coming from? That's just a number. That almost cancels. And it's times h cubed. Get your equation as simple as you can. And then, now you can take the derivative. With respect to what? dt. You could do the derivative with respect to RH, but that's not what we want. We want how fast. Now, this is a constant. Remember, I can pull that through. It's been a while since we've done calculus. Remember, I can pull that through a constant? You got your phone out? Oh, give it to me. No, you're not. Give it to me. Okay, that's fine. You can owe me an hour. Give me your phone. Put your both hands. It's gone. You're the second person. Emergency call. No, we're not doing that right now. Oh, second person today. I knew I'd get him. Okay, you guys should be done with this by now, right? Eric's done with it. That's your choice. I think that's silly, but that's okay. What's the derivative of h cubed? 3h squared times dh dt. Okay. Right? Can you simplify that? dv dt is pi over 4 h squared dh dt. You won't get back to the end of the day. Okay, can I put anything in here? What's dv dt? 8 equals pi over 4. What's h? Eric, what's h? It's 4. Now, I'm not going to square that. I'd probably do it wrong. Because what's going to happen to the 4s? They're going to cancel. So 8 equals 4 pi dh dt. So why would I use a calculator? It actually isn't faster. It's slower. Because, by the way, 8 over 4 pi is just fine. But I like to simplify. Because if it were multiple choice, you would have to. And this problem would be a multiple choice because it's not particularly difficult, even though you might think it is. Where did the 4 come from? Ask. H is 4. Can, I wouldn't, but that's my thing. Remember, you've done the hardest stuff. Okay, one more problem for you to try. Oh, let's just say 4-1. Forget that. Let's just cut it out. You've got an assignment sheet. Try to get halfway through. Do you guys know the formula for the volume of a balloon or a sphere? 4/3 pi r cubed. Hey, go ahead and try that. Eric, you're not punishing me.